Miss Graham's.
5.
Yep.
My guess is A.
All right, these questions will show up on the final and everything else that we have to worry about. So we'll go through them and just practice a little bit. You do get a study guide for December. It's not much. For the May, you get an extensive, like trig, a lot of stuff. Okay? May is over everything. That's why it takes longer. In trig, we spend a week or two doing it. That's what we're going to do again in May. Maybe. 5 questions. First, the conclusion. Quiet, please. The conclusion of Rolle's theorem states there exists a C between A and B such that, quiet, please, the derivative equals 0. F of B minus F of A equals the derivative of C times B minus A, or F of A equals F of B. It is A. The derivative equals 0. B is the restatement of the mean value theorem. C is the hypothesis. Quiet, Nick. C is hypothesis of the Rolle's theorem, where F of A equals F of B. You need to start reading what things mean because you're going to be asked paragraph questions in the second semester. Okay? C was the hypothesis of Rolle's theorem. Okay? Has to be a continuous function. The y values have to equal. And A has to be to the left of B, so on and so forth. This one, what's the limit as x approaches -3 of the function f of x equals 4? What do you think it's going to equal? Yeah, it is. You put -3 into the equation. What do you get out? You get out 4. Okay, so it should be A. That's obviously incorrect. I don't know. If f of x equals 6x plus 1 cubed, then the slope of the normal line to the graph at x equals 0 is blank. Work this one out, please. You're going to have to use the mean value theorem and find the equations of normals and tangent lines. I also want to know what is the slope of the normal line at x equals 0. It should take about a minute to a minute and a half to do. All you need is the equation. Yep, and you have to use a chain rule. Yep. So the derivative value is going to be 18. So what's the normal line going to be? -1/18. So if the derivative at 0 equals 18, then the normal line is the opposite reciprocal. So that should be -1/18. Because it says the normal line to the graph at x equals 0. Okay? -1/18. No, it's not mean value theorem. No, I said we're going to use the mean value theorem to find other slopes using the derivative. This is practice doing that. You get it?
Yeah, got it.
Good. All right. 2 more. Quiet, please. Nope. On this one, the conclusion of the mean value theorem states there exists a C between A and B such that f prime of C equals 0, f of B minus f of A equals f prime of C times B minus A, or f of A equals f of B. It is. It's B. Make sure you know the alternate way of writing it. Some people use this exclusively. Rolle's theorem, the mean value theorem, rewritten in a linear fashion instead of a quotient. Okay? All right, here we go. Do you remember how to do this? What is the absolute maximum of this function over the closed interval -1 to 3? We talked about this during this chapter. Possibly. No, that just gives you a vertex, not necessarily the absolute maximum. Remember, on a closed interval, there's three things to do. First one, calculate the endpoints, the y values of the endpoints. The second one, set the derivative equals 0 and calculate those y values. And third, compare all the y values you got to see which one's the biggest. You do. So for the first one, f of negative 1 equals 3 plus 10 plus 7. So it equals 20. F of 3 equals 27 minus 30 plus 7. So that equals 4. And now I have to find out where the derivative equals 0. 6x minus 10 equals 0. X equals 5 thirds. Is that right? So the function value of 5 thirds equals 3 times 25 ninths minus 10 times 5 thirds plus 7. That's a 3. So 25 thirds minus 50 thirds plus 7. Well, it's going to be negative 4 thirds when you're all said and done with it. So the absolute maximum is going to occur at the endpoint when x is negative 1 and y is 20. Okay? Those are the three things you do on a closed interval. Calculate the endpoints, derivative equals 0 or undefined, and then compare the y values. Okay? And x equals, that should be at negative 1. Ah! All right, moving on. 4.2. Oh, sometimes kids get in there and change them all the time.
Don't worry about it.
No, 4.22, the mean value theorem, day 2. All right, on this one, if f of x equals x minus 1 to the 2 thirds, and if f of 0 equals f of 2, but the derivative doesn't equal 0 for any x between 0 and 2, why doesn't this contradict Rolle's theorem?
Because the derivative, you can't do the derivative. Because if you plug in 0 for the derivative, it'll be in the denominator.
If I plug in 0 for the derivative,
It'll be in the denominator.
it'll be in the denominator. But yeah, but doesn't Rolle's theorem say f of a equals f of b? Then there has to be a c such that f prime of c equals 0?
So the kids are changing.
I don't know. It's something to think about, to ponder, if it's true. Hmm? Well, yeah, but what is Rolle's theorem? What does it say? That's the conclusion. What's the hypothesis?
F of A equals F of B.
Keep going. There's more to it than that. You gotta look at the fine print.
X is different.
F of x is differentiable. Is this function differentiable for all x's from 0 to 2?
No.
What's it not differentiable at?
But it's not equal to 0. Right?
Where isn't it differentiable at?
0.
What's the derivative? You keep saying the same answer, and I'm not recognizing that as correct. So f prime of x equals negative 2 thirds times x minus 1 to negative 1 third times 1. That's the derivative, isn't it? Positive. I was going to put the, there we go. So this means it's actually f prime of x equals 2 or 3 times the cube root of x minus 1. Where is it not differentiable at? 1. Is 1 in the interval from 0 to 2? Yes, it is. That's another important hypothesis in Rolle's theorem, and the mean value theorem. Not only does the function have to be continuous, but it has to be differentiable. Differentiable means you can put any number you want in there and get out a value for the derivative. In this case, it's not differentiable, so it doesn't contradict Rolle's theorem. Okay? Therefore, it still works. Because this isn't differentiable for all x's from 0 to 2. You just read that was part of the hypothesis. The function is continuous and differentiable for all x's over the interval. No. It says it has to be both. If there's a flaw with one or the other one, then Rolle's theorem is not going to apply. In this case, Rolle's theorem doesn't apply. Right? It doesn't apply because the function is not differentiable. No, that means you can't use it. It doesn't mean it's wrong, it just means it isn't valid to use. It doesn't match all the criteria. Okay? If one thing is false, the whole thing is false. Okay? So you can't use it. It doesn't make the theorem invalid, it just says it's not differentiable over the given interval. Therefore, you can't use it. Okay? If you run into that problem, you know why. It's part of the hypothesis. Okay? Pretty soon, if you stick with it long enough, you'll start reading these things for a little bit more information, I think. All right, that was the opening slide. Hopefully this goes a little bit better. I know. Determine if the given function satisfies the hypothesis of the mean value theorem. The mean value theorem states, is the function continuous? Is this function continuous from -3 to 6? Yes, but why? One big word. What kind of equation is this, or function, sorry? It's a cubic function, but it's also a polynomial. A polynomial is continuous for everything all the time. That's good. So f of x is a polynomial. That means it's continuous and differentiable. There's no fractional exponents. You remember that about polynomial. A polynomial has to have whole numbers for integers. The last one, we had a fraction. So that caused a little bit of a problem. So this is good. It's continuous. It's differentiable. Now all you got to do is find c. So get after it. It's been 2 days since you've done any of this on your own. So give it a shot. Blow the rust off. See what you got. Because I can take the derivative, I can put any value I want in because there's no denominators, there's no negative exponents, and there's no radicals. Okay? Okay, we already talked about the hypothesis. So everybody knows it satisfies the mean value theorem, right? It's a polynomial, it's continuous, and it's differentiable for everything. Now we can go find our value. These are just some of the words on how to state your reasons, okay? So, what's the average rate of change? Anybody find it yet? Chase, you look pretty confident. What is the average rate of change between -3 and 6? Oh, go ahead. Well, you put -3 in, you have -27 minus 12, -39. Put 6 in, 216. 240, thanks. Plus 24. Yeah, wasn't it 216 plus 24?
Yeah.
Yeah, 240. I like that, the 216. I was pretty impressed I could cube 6 that quick. Then you guys shot me down, ruining my dreams, keeping me down, kicking me. 240 is the whole thing. All right, Chase, what'd you get? I did the worst part for you. It was? You don't need your calculator. I didn't use it. What's 240 minus 230? Negative 239. 279. 240 minus a negative 39 is 2. What's 6 minus negative 3? 9. So it's 279 divided by 9. 31. No, I said 31 equal to derivative.
Wait, why didn't you add that?
Huh?
Why did you set 31 equal to the derivative?
Well, because I did 240 minus a negative 39 is 270. 279. 6 minus a negative 3 is 9. Divided it. Yeah. Well, you can write it like this.
What was the one?
That should be 31, shouldn't it?
No.
Oh, I multiplied. I divided, then I subtracted. Okay. Hey, if it's plus or minus 3, which one's it going to be? Is it both? Can it be at the end point? I think it has to be on the open interval.
But it's, you have to have a bracket there in bracket.
I know. I'm saying the conclusion of the mean value theorem says there exists a C in the open interval from negative 3 to 6. So it can't be at the end point. It has to be in the interval. Okay? No, it's just from reading things carefully. So the answer would be 3. Okay? No, I'm saying the answer is going to be 3 because negative 3 can't be an answer. Because the conclusion says it has to be parentheses at the end. Okay? I think it says open interval.
On the top it says C and A, B, and it's an open interval.
Yeah. So it has to be in the open interval. Ooh, we learned something today. Next! I can do that. Oh my gosh. Look at all these words! You don't have to write them down, you just have to know them. Quiet please, here we go. If a function is defined to be a linear function, then prove that f satisfies the hypothesis of the mean value theorem on every closed interval a to b. Well, that should be easy. What's your favorite linear function? Oh my gosh. What's a linear function? How about y equals mx plus b? Did you jot that down? Y equals mx plus b. Yeah.
Are you going to vote on the Spanish alternative?
Yes, I am.
Are you really?
Yes.
Are you voting for that?
I'll get to that later. Let's focus on this. Focus on this right here. All right. If y equals mx plus b, does this make sense? Y equals mx plus b. First of all, that's a polynomial, isn't it? Watch this very carefully. I'm going to change it to function notation. Mx plus b. I change y to f of x. Now, it's a polynomial, so it's continuous. It's a polynomial, so it's differentiable because there are no fractional exponents. The fractional exponents are what give you fits in equations. So, that's good. That satisfies the hypothesis. Is this a true statement? Does the function value of b minus the function value of a equals b minus a What's the derivative of my linear function? M. Have you ever seen this before? No, equals M. It is. That is the definition of slope. It's true for all values of c. That's a true equation. That's a definition. That's like what you used in geometry. You use definitions to prove things. Everybody knows that f of b minus f of a over b minus a equals m. That's true for any linear function. So that means for any linear function, the average rate of change equals the instantaneous rate of change. Does that make sense? F prime of c equals m. No matter what you put in, it's going to equal m. That means f prime of c equals the average rate of change for all c. Okay? You're not going to get answers algebraically in steps like you would for numerical problems. You have to string together thoughts for word problems. Hey, Ingrid, focus this way. There you go. Nice, better.
What's the answer?
The answer is all that. And how you, the answer is like a geometric proof without the statements and reasons column. You have to have your initial statement, a little bit of work, then your final conclusion. The conclusion is that f prime of c equals f of b minus f of a all over b minus a for all c. That's true. It's going to work for all c. Okay, I used my nail to write that. It's fine. It's the best I got. Oh, it's going to come up here and print here in a minute. There we go. F prime of x equals m, right? Well, that means f prime of n equals the average rate of change for any c. That's just what we wrote. F prime of c equals m, which equals f of b minus f of a all over b minus a. It equals the average rate of change.
So because of that,
Yeah. Yeah. Since it matches the hypothesis, the conclusion has to be true. And since you know that that equals the average rate of change by definition, you're done. Kind of like geometry. It's been a while since you've done geometric proofs.
a while, 3 years.
Yeah. Or, if you go back to last year, you did the trig identities, steps. And each step had a statement that you strung together to make a problem. Okay? Oh, nice. We've only got 15 more slides. How many we got? Yes! I know. Let's get this party started. Ching! 3 things. I didn't have any 3 things.
Three things. Homework.
Oh! That's 4.2, number 3. I don't know. 3 things. String your thoughts together on the word problems. Know what differentiability means on your hypothesis, and read the theorems carefully. Okay? Homework is page 182, 19 through 25 odd. Apparently you're having time in class to work. Use the time. And I'm going to shut this off.